All right, so let's look at an example of an effective collision between our two reactants here. So we've got our NO2 with one nitrogen atom connected to two oxygens. And we've also got our carbon connected to a single oxygen here. So what we're going to observe now is going to be a high energy collision between our two reactants, which are on the left-hand side of the equation here. And it will be a collision that meets the activation energy, and it'll satisfy the second need for an effective collision, which is a convenient orientation. So the parts of these reactants that collide are going to be the ones that need to collide for the reaction to take place. So let's have a look what happens. So we have a quick approach between the two components where the carbon of the CO collides with an oxygen of the NO2. And you can see after that collision, we get a breakage between the chemical bond. So you can imagine that whatever chemical bonds are connecting the nitrogen and the oxygen here, then they are going to be broken after the collision, and that allows the atom to change position through rearrangement and form attachments to the carbon atom instead in this way. So it all happens very quickly here, but because it's an effective collision, the chemical reaction goes forward. So we have the collision, which allows bond breakage, atom separation, which moves the atom through atom rearrangement, and then we get bond formation more or less straight away, where the carbon will be bonding to the new oxygen. So breakage, bonding, and done. So what do you think would be the evidence that the chemical reaction has actually taken place if you look at this animation here? What can we say that, yes, the chemical reaction took place because of this? Well, for one thing, we've got new components or new molecules that we didn't have at the beginning of the reaction. So that's the basis of what happens in a chemical reaction. You're changing what you have at the beginning into something new. And we do that by following those three steps of a chemical reaction: bond breakage, atom rearrangement, and bond formation. Not all collisions, though, are successful. So we're going to have a look at an unsuccessful collision. This time it's an unsuccessful collision because the molecules are colliding in an inconvenient way. So remember, for this one to be convenient, we had to have the carbon colliding with the oxygen, because that's what is going to allow the formation of our products in this reaction, to basically transfer an oxygen from one molecule to the other in such a way. But what about if it's not the oxygen that collides with the carbon? What about if it's the nitrogen that collides with the carbon? What happens then? Well, in that case, it's an inconvenient collision for this reaction. So that instead of the reaction proceeding, the reactants just bounce off each other. So you can see, even though they approach quickly, they are bouncing off each other because it's an inconvenient orientation, which makes it an unsuccessful collision. So essentially, the wrong atoms are colliding, meaning that the chemical reaction cannot begin. Basically, it comes down to which chemical bonds need to be broken. Because the chemical bond between the nitrogen and the oxygen needs to be broken, then we need to have this carbon on the other reactant colliding with this oxygen. And when that doesn't happen, we now have an unsuccessful collision. There is one other way we can have an unsuccessful collision, even if there is a convenient orientation. So even if the right atoms within these reactants are colliding, you can still have an unsuccessful collision. How could this be? Well, it would be to do with the energy of the collision. So if the collision is not enough to provide the energy to start the reaction won't take place. So we call this a low energy collision that doesn't meet the activation energy. So one thing that could cause a low energy collision is if the molecules aren't moving that quickly. So you can see this time that the molecules are moving much more slowly than when it was a successful collision. So they approach slowly, and even though they hit in the right spot to, in theory, break the bonds, the collision doesn't provide enough energy to generate the activation energy which is needed to start the reaction. So looking back at our effective collision, this has both of the requirements for the reaction to happen: high energy due to the reactants approaching and colliding quickly, and also convenient orientation. So if we see the result of that, we get the chemical reaction happening, which is allowing the rearrangement of the atoms and then new products forming there. Whereas for the unsuccessful collision that was due to inconvenient orientation, we had the wrong atoms colliding, even though they were approaching each other quickly. And the second way we had the unsuccessful collision was if the reactants were approaching each other slowly and therefore not able to generate enough energy to start the reaction. So it goes back to a point we saw on the slide earlier, the fact that most collisions between reactant molecules actually do not result in a chemical reaction, because they need to have these two things met. They need the collision energy to be high in terms of meeting the activation energy, and they need to be convenient collisions. These collisions are events that are basically happening randomly, but they continue to happen again and again. So eventually the chemical reaction will take place. It just depends how often they're colliding to basically determine how often the reaction will take place. Alright, so we've got a question to have a go at now. So when the reactant molecules above collide, so the reactants are on the left-hand side here, our NO and our O3, what factors determine whether a chemical reaction will occur? So we've discussed a few of these factors on the previous slide, so now would be a great time for you guys to have a go at putting this into practice. So pause the video and have a go at trying to work out what's going to impact on whether we have our reactants converted into products through this chemical reaction. So in this section we've been talking about collisions. So basically the question is asking what is needed for an effective collision. So the chemical reaction will only take place if you've got an effective collision between reactants. So the reactants in this case are NO and also O3. Okay, so what is needed for an effective collision between these two? Well, we need to meet the activation energy. So this corresponds to having a high energy collision. So you could say that in either way. The collision either meets the activation energy or is a high energy collision. So essentially this just means that the collision has to have enough energy to start the reaction. Okay, so that's one thing. So what is the other thing we have to consider, as well as the amount of energy that's being generated when the NO and the O3 collide? The other thing is it has to be a convenient orientation between the two reactants. So in this question you don't necessarily have to say which is the convenient orientation, but you do have to have the right orientation. So if you're really keen, you could have worked out the difference between the reactants and the products is that one of the oxygens is actually being taken off the O3 and is being transferred onto the NO. So that would mean that one of the oxygens would have to collide with the nitrogen, because the nitrogen is the component that would have to form the new bond to the oxygen. So that's pretty tricky to work out, but hopefully you were able to get one or two of these points in terms of what is going to dictate whether the reaction occurs, and it is whether you have these two factors met. The collision between the reactants has to have enough energy to start the reaction to meet the activation energy. So we need enough activation energy, and we also need to have a convenient orientation between the colliding reactants. So if you have those two factors being met, then the reaction will take place. And we can see an explanation for this as well here. So a little bit more detail on this answer. So essentially, For the chemical reaction to take place, we need to have the collision providing an energy that is equal to or greater than the activation energy. So keep in mind that each different chemical reaction will have a different activation energy. No need to memorize what activation energies different reactions have, but just to realize that depending on the reaction, the activation energy will change. So once the collision energy is greater than the activation energy, provided there's a convenient orientation, we then go through the process of a chemical reaction. So the collision energy will break some of the bonds within the reactants, maybe not all of them, maybe all of them, just depending on the reaction, which allows some of the atoms to rearrange, take on new positions, where we can then form new chemical bonds to get the product compounds, which in this case are NO2 and O2. And the second thing we need to meet is the orientation, so they have to collide in the right way. So in this case, the oxygen has to collide with the nitrogen to allow one oxygen to come off the O3 and now to become part of NO2. So you can see that in the representation down the bottom here. We've got the oxygens shown in red and the nitrogen in blue. So we need a collision between one of the oxygens in O3 and the nitrogen in the NO, and that essentially will transfer that oxygen over onto the nitrogen containing molecule, which we can see on the product side here, which is equivalent to NO2, and we're left with an oxygen that contains two oxygen atoms there. So we've got the oxygen molecule product that contains one less oxygen atom there. Okay, so now we've reached the point in the session where we can have a go at some of these revision questions. So remember, these contain the concepts that are most important to your understanding of these sessions, and they're closely linked to the assessment. So I really do encourage you to log on to the LMS and do the first 4 questions of the revision quiz to check your understanding of what we've been through so far. You can actually check your answers as you go through these revision quizzes as well, so you'll get immediate feedback on how you've actually been able to interpret what we've gone through so far in the session. So to summarize what we've seen in this session, we had a look at the chemical reactions in a little bit more detail. We reviewed the fact that chemical reactions can be summarized by chemical equations. So we've got the reactants on the left-hand side and the products on the right-hand side, and the arrow between the reactants and the products shows the progress of the chemical reaction. And remembering back to the previous session, no atoms are created or destroyed during a chemical reaction, they're only rearranged. So that's why we need that rearrangement step during the process of a chemical reaction to create our new substances, which are the products. So it is the collisions between different molecules or atoms that are the reactants that drive the chemical reactions. So we had a look at some of the aspects of these collisions that are going to dictate whether or not the chemical reaction takes place. So essentially it's the collision between the reactant molecules that provide the energy needed to start the chemical reaction. So for a collision to actually result in a chemical reaction, it had to satisfy 2 things. Firstly, the collision had to have enough energy to meet the activation energy of the reaction. So they had to collide, the reactants had to collide with enough energy to meet that activation energy and allow some of the existing chemical bonds to be broken. So that's what happens at the beginning of every chemical reaction. As well as having enough energy in that chemical collision there between the reactants, we also need to have a convenient orientation between those colliding reactants, which basically means that the correct atoms within the reactants are colliding to break the chemical bonds that are needed to be broken, so we can then get rearrangement of those atoms to form the products. So if a chemical reaction is of high enough energy to meet the activation energy and is a convenient collision, that will allow the chemical reaction to begin. If either of these factors are not present, for example, if the activation energy is not met, then you do not get the chemical reaction. And even if the activation energy is met, if the collision is not convenient orientation, then there's no reaction. So this is basically why most collisions between reactants don't result in a chemical reaction. But there are enough of these collisions that do result in a chemical reaction, so that's what we're focusing on once these two factors are met.